Lesson 3, Inverse Trigonometric Relationships. So you should know about sine, cosine, and tangent from your previous math experience. And now we want to look at the inverse trigonometric relationships. So there's 3 of them. One corresponds to each of the original 3 ratios. So we have cosecant, which is 1 over sine theta, or if you're looking at that reference triangle that's created on the unit circle, it's radius over y. If you remember when we were looking at the sine, we were just using the y coordinates. So now it's 1 over the y. The secant, which is 1 over cosine theta, and then the cotangent, which is 1 over tan theta, which is x over y coordinate. Just keep in mind that tan theta is sine over cos, and if we're taking the inverse of that, it's just going to be cos over sine. So really simple and straightforward. A lot of the work that you'll be doing in this section is just flipping the value and then finding the new coordinate. If there's a radical in the bottom, you just need to do that multiplication, but we'll get there and we'll go through it. So I want you to just be conscious of the fact that we are creating fractions here, and therefore we have to make sure that we recognize that if the bottom of the fraction becomes a 0, that value would be undefined and there would be no graph at that point. So for example, in cosecant, what are the values of sine theta where theta cannot have a value? So sine theta equals 0 at 0 degrees, pi, or 180, 2 pi or 360, 3 pi, etc. It's when the y coordinate equals 0. That would give you 1 over 0 in this fraction, and therefore it would become undefined. So just be conscious of that when you're solving these problems, that if you have a 0 in the bottom, that happens. With coordinate, we can find a lot of information. We can actually find all 6 trigonometric ratios. So we have this point, -3 over 5, -4 over 5, and it's shown right here on this diagram. Remember that the sine and cos are just your y and x values, and then your tangent is y over x. So when you go to do your cosecant, secant, and cotan, if you have the first original 3, all you're doing is just flipping the value of the fraction, and that will get you to the proper answer. So you can see how that happened there. Once we realize that cosecant, secant, and cotan are inverses of our original functions, we can use that information to be able to solve for what the value of those ratios are equal to. So for example, in this one, secant 315, the reference angle for 315 is 45 degrees. So if you look on your unit circle here, it's at 7 pi over 4, or 45 degrees. Okay. Now you have this set of coordinates, 1 over root 2, -1 over root 2, positive x, negative y. And your secant 315, all you're doing is taking that x value and flipping it over, root 2 over 1 or root 2. Cotan is much the same. Tan of theta equals y over x. So to get the cotan of theta, you just flip it over and get x over y. And therefore, the cotan of 270 is 0 over -1, which of course is equal to 0. In these bottom 2 examples here, you get into that situation where the radical number ends up on the bottom of the fraction in your solution, and you just need to take that one last step. So the cosecant of 5 pi over 3, you want to find the sine of 5 pi over 3, and then just take the reciprocal of that. So you're just going to flip it over, -2 over root 3, multiply both top and bottom by root 3, and your final solution will be -2 root 3 over 3. Prior to this, the fractions that we're coming up with and the responses that we're coming up with in these questions are considered exact values. We can also use our calculator to find an approximate value of the angle that we're given. So two things to be conscious of. Number one, if the angle is given in radians like it is in these two, then you need to make sure that your calculator is in radian mode. Typically you'll use a button that looks like this, DRG, for drag. Okay, and you'll have a couple different modes on your calculator. The two that we're using in this course are D for degrees and R for radians. So just be conscious of switching back and forth between that. It will give you the wrong answer if you're not in the right mode. The other thing that you need to be conscious of, your calculator is only going to work one way. Typically, calculators that show you the formula that you're typing in, you will do the first instruction here. You'll press the function and then put the value in. So you would literally type this out, cosine 260 or tan 7 pi over 5. Some calculators, though, they don't show you that on the display. And those ones, you traditionally put the number in first and then press the function. So you would enter in 260 cos or 7 pi over 5 tan. Only one way is going to get you the right answer, and then you know which way your calculator works. So test it out on these sample questions, and only one of them will give you an answer. The other one will give you a syntax error. So for these, you're literally just punching it into your calculator to get the correct answer. Please do test it out so that you know how to do it, and make sure that you can get the answers given. What we can do once we're given these approximate values of sine or cosine or any of the inverse functions is that we can determine what the angles equal within a given range of values. So we have sine theta equals 0.879. If you do that in your calculator in radians, that's going to give you about 1.1 rads, which is right here. Okay, but you need to look at this and see that the value of theta falls between 0 and 2 pi. So anywhere in this whole 360 degree or 2 pi rotation. So we know that sine theta is positive in quadrant 1 and quadrant 2. So you will be able to, once you have this value, you'll just use it as a reference angle and solve for the angle that's missing. The same thing happens over here in cosine. Now it's negative in our response. And again, it goes from 0 to 2 pi or 0 to 360. So to find the angle, if you're given the value of cos theta, you're going to use your second function button on your calculator, or the cos to the -1. And you should get an angle of 111 degrees. Now cos, of course, is our x value in our coordinate. And x will be negative in quadrant 2 and 3. So once you have this angle, 111.5, you'll be able to calculate the reference angle, 68.5, and then add it onto 180 to find the other reference angle, which is 248.5. Something to be conscious of is to pay attention to the domain and the spread of values that they give you. Notice here we have negative 180 as one of our values. That tells us that we're going to be moving in a clockwise direction from the origin. So once you've found this angle, tan equals √3, our angle is 60 degrees, our reference angle, then you'll know to move towards negative 180, which is here on the coordinate plane. It's going to be 120 degrees from here. So note that one angle is 60 degrees and the other is negative 120 because tan is greater than 1 in quadrants 1 and 3. So you'll need to have a response here and here. The same thing here in secant 2 over √3. We will get the same responses here to be able to solve that our reference angle cos theta is pi over 6. And then from 0 to 2 pi, going in this direction, theta will be equal to pi over 6 and 11 pi over 6. Going from negative 2 pi, which is here, back to 0, again in that direction, we're going to get negative pi over 6 and negative 11 over 6. Sometimes we'll be given points on the coordinates that are not on the unit circle, and that's okay. We can still just use the Pythagorean theorem to determine what the value of our coordinates and theta would be. So for example, we have superimposed this triangle here, 3, 4. Of course, our Pythagorean triples, we know the radius will be 5, but you can always easily solve for that using the Pythagorean theorem. Now, once you have this, you still have x, which is cosine, y, which is sine, and you can still determine all of the trigonometric ratios. So our sine theta is y over the radius, 3 over 5, cos theta, x over the radius, negative 4 over 5, and tan theta, y over x, negative 3 over 4. And then, of course, the cosecant, secant, and cotan are just inverses of that. Now, you might be saying, why are we all of a sudden having a denominator there? And you need to remember that in the other examples, those coordinates were on the unit circle, so y over r still exists, but r is 1 when it's on the unit circle because of the radius. So if the points are not on the unit circle, just make sure that you're conscious of that. You should probably end up with a fraction. The last type of problem that you can get with these questions is you'll be given the coordinates of theta, and you'll need to find the reference angle for that. Just be conscious of the direction that these questions are asking you to move. So of course, if it's asking you to determine the coordinates of p theta plus pi over 2 or 90 degrees and p theta minus pi over 2 or 90 degrees. Remember, this way you're moving counterclockwise and this way you're moving clockwise around the unit circle. So very simply, you just move about the unit circle and find the new coordinates for the values that are given. Beyond this, you have some practice questions that you can complete before you go to class tomorrow.